Thank you, George, and thank you all for joining the March 2017 edition of the Sustainable Materials Management Web Academy. We are happy to have you participating. This 90-minute webinar is hosted by the U.S. Environmental Protection Agency to provide training and a networking opportunity to state and local governments, non-governmental organizations, and other stakeholders interested in sustainable materials management. Today's EPA-hosted webinar will feature 4 speakers that will discuss some of the challenges to managing lithium batteries in the waste management system. This will include understanding how lithium batteries work, how they can impact a waste management facility, how they can be properly managed by consumers, and communicating proper management to residents. Lithium batteries are essential to many of the modern-day conveniences that we've all come to rely on because they can store a large amount of energy in a small volume compared to other types of batteries. These batteries run our cell phones, portable computers, wireless headphones, power tools, backup electronic memory on countless other devices, and have uses in many other products. But as these batteries become more ubiquitous, lithium batteries, or the devices they are in, are unintentionally ending up being managed incorrectly at their end of life and become one of the many contaminants the recycling industry is dealing with today. This could be because of the owner's good intent that the recycling facility will know what to do with it, the owner's incorrect interpretation of the various markings on the battery, or other confusing messaging on how to manage batteries. The end result is that batteries are ending up in the waste and recycling hauling trucks or in material collection facilities where they may come in contact with other waste processing equipment. This equipment can damage a battery, causing the battery to start a fire which can spread to the surrounding waste material, presenting a risk to the facility and the workers in it. Just last week, there were reports of a battery-started fire at a MRF in the borough of New York City, which had impacts beyond the facility because the local railroad that runs along the side of the facility also suspended service. And in Maine this past December, there was a smaller fire started by an improperly disposed lithium battery and a material waiting to be sorted. Fortunately, the fire was quickly isolated and extinguished by rapid employee action, which prevented injuries or damage to the facility. You can find video and more stories on the internet, such as this one from EcoMaine, where they also have information on how to communicate battery safety to their customers. We will take 1 or 2 burning questions after each presentation, and if time permits, we will have a longer question and answer session at the conclusion of all 4 presentations. Please feel free to type your questions throughout the webinar. Moving into today's webinar, please note the disclaimer. And now to our speakers. I have the pleasure of introducing our first speaker, Jeff Spannenberger, who is a senior engineering specialist at Argonne National Laboratory, where he leads energy research activities ranging from bench-scale testing to full-scale plant installations. The focus of his work is material recovery and recycling from waste streams with a concentration on battery recycling. Today, Jeff will be providing us an introduction of how lithium batteries work. So thank you for being with us today, Jeff, and go ahead.
Okay, thank you, Chris. Appreciate it. I'm going to be talking a little bit about the basics of lithium-ion batteries, and I am also going to talk briefly about some current recycling processes and the challenges that they face. But first, I'm going to tell you a little bit about Argonne. Argonne is a multi-purpose Office of Science lab located near Chicago. It's owned by the Department of Energy, managed by U Chicago LLC. As you can see in the slide, there's obviously many other laboratories. Some of them are operated by Office of Science. There are other more single-use facilities. So more about Argonne. There's about 3,300 employees here. We have 1,600 scientists and engineers, 300 postdoc researchers. I believe actually we're up to over 8,000 facility users, and we have about $750 million operating budget. We perform both basic and applied science work, research, including high-performance computing, computational science, energy storage, obviously that's why we're here today, manufacturing, connected vehicles, a lot of vehicle work we do, nanomaterials. We work with other labs, academia, industry, and other organizations to accomplish our goals. quick couple of examples of some of the things that have come out of argon include pioneering the modern nuclear power plants. We recently had some splash on the oleo sponge, which absorbs 90 times its own energy, its own weight in oil from an oil-water mixture. We also have a chemistry in the cathode material in the Chevy Volt. You've been in the battery research area for about 50 years, starting out in high temperature, moderate temperature lithium batteries. Then it moved to, in the 90s, when the lithium ion battery came about, we phased into that. And then 2012, we had J. Caesar, which moves beyond lithium ion. Because we're a multi-dimensional facility, we work across the value chain. Real quickly, if you start at the system level, we need to figure out, using models, we can determine what the batteries need, what the function they need to do, how they need to perform. We discover materials, we characterize those materials. We'll test those materials in new electrodes and cells, and if they look promising, we can optimize and scale up that process. We also have what we call a CAMP facility here that manufactures batteries, 18650 format pouch cells like you see in a cell phone, things like that. We test our batteries. We have a facility where you can send your batteries and have them compared to other batteries using the same parameters depending on the application. We also have a cell diagnostics and modeling. We want to find out why batteries degrade. Otherwise, we wouldn't have this whole discussion here today, really. We wouldn't need to get rid of batteries, right? So, and of course, recycling. Okay, a little bit about other chemistries and how lithium ion lines up. In the lower left is the least energy dense battery chemistries, and as we go up and to the right, we're going to get more energy dense. So we start with lead acid, and it may not be that energy dense, but it's still very popular today because of its low cost, high current capabilities for starting vehicles. That's where they're predominantly used. And they're very impressive recycling infrastructure. Next, moving up, is NiCad, nickel metal hydride. Again, we're getting more energy dense, and now we're into the lithium ion stage, and that's where we are today. So a little bit about the lithium ion battery. All of these chemistries have certain things in common. There's an anode, there's a cathode, and there's an electrolyte. The lithium ion battery works by moving lithium ions back and forth between the anode and the cathode. There's a separator between the anode and the cathode, and that protects the battery from shorts, and shorts are bad. That's what causes a lot of our challenges in the MRFs and things that we're going to be talking today. There's also an electrolyte that allows these flow of these lithium ions to go back and forth. So in the charging state, when you're charging a lithium battery, the electrons are forced to the anode, and the lithium ions move from the cathode in this picture over to the anode. And then when you're using your battery or discharging it, the lithium ions move back to the cathode, and as a result, the electrodes are forced over to the cathode to balance the charge, and we use that energy in our device. There are a lot of different chemistries involved with lithium ion batteries. I put some of the names in there. You know, people like to talk about LCO and NMC or NCM. So there's a lot of different chemistries. Another thing I want to point out, just to clear up some nomenclature, is on the lower center there's a cell, module, and pack. A cell is a single unit, I guess you could say, the least voltage you can put together, or the least power. One cell, like a AA battery, would be one cell. Then if you put a bunch of them together, you have a module, and if you put a module together, you have a pack. So there's a lot of chemistries. Why do we have so many chemistries? Well, there's a lot of different applications. LCO, one of the chemistries shown on the previous slide, is a high energy dense material. This is what's found in our smartphones, our computers, and what we're really here to talk about today. As you move down, there's NMCs and LMO chemistries that get into vehicles. They're used for different reasons. They have different performance characteristics that are required. And then phosphate chemistries, that's the common one. Try to go through the noise of this sound. But the phosphate is a common chemistry used in power tools. Thank you. Okay, a little bit about chemistries and voltages. Now, because these lithium ions have so much energy, part of what gets us there is the fact that they have high voltage. This high voltage doesn't allow us to use water-based electrolytes, and so we use organic electrolytes. One of the inherent properties of these electrolytes is that they're flammable. So we have high energy chemistries, flammable materials, and this sets the stage for the challenge that we're talking about today. Wasn't quite sure how to fit this in, but I'll put an example about another challenge that we face. The pictures below of these starter batteries are different chemistries. The one on the lower left is a lead acid battery. The one on the upper right is a lithium ion battery. So I'm going to show a video in a little bit to show one challenge, but before we go there, I want to say that there's talk about bans of this lead acid battery because lead is of a concern. But I'm not one to make an opinion here, but I think that there's a lot of thought that needs to go in that, because currently there's the lead acid battery has a wonderful model of how to recycle. They recycle 99% of their batteries, and that infrastructure is not yet set up for lithium ion.
Yeah, that one.
So moving on, I have a little video. So this is a lead acid battery recycling facility, and presumably that is from a lithium ion battery getting into the mix. There's another view. So this is a problem that the recyclers are seeing with mixtures of batteries. So that segues into some recycling information. There's a lot of reasons for recycling, we all know. Potential for cost reduction is one of them. Reduction of emissions, so we don't need to mine these materials, and which produces more emissions potentially than it does processing in a recycling facility. As I mentioned, a reduction of use of our natural resources. The chart that I have shown on this slide shows the blue line is the projected demand of lithium use in these lithium ion batteries. The yellow is if we recover those batteries, and then the gray one is how much virgin material we need to produce. And as we collect more, we require less to continue on our trend upward. The current technologies that are out there today are pyrometallurgical based and hydrometallurgical based. I'm not going to go into detail, but they both have pros, they both have cons. The revenue streams from these products are based predominantly on cobalt, however, and that's a key to understand, because as we understand that cobalt is expensive, the most expensive component in these batteries, manufacturers are trying to get away from cobalt. So a challenge that's turning around to get us is we're not using cobalt in our newer chemistries, so that's going to decrease the incentive for recycling with pyro and hydrometallurgical processes. A way around that is through direct recycling, where we recover a cathode material out of the battery and rejuvenate it, if you will, and make a new cathode to put into a new battery. And in that case, we maintain the value of the cathode rather than the constituents of the chemistry. This shows you, if you look at this chart, you can see that the higher the cobalt, the higher the cost per kilogram of the cathode. So LCO has the most cobalt, NMC has the next highest, NCA is a lower cobalt, LMO and LFP, lithium iron phosphate, they don't have any cobalt in them. So this is another reason you can see that we run into this challenge as we get to a more cobalt poor chemistry. So we have these challenges all across, and I'm going to throw a little, well, these are just some pictures, I guess. Well, this is important. So the electronics batteries that we're talking about today on the left side are what you find getting into the MRFs, and on the top right, your power tools getting into the MRFs. They have a collection problem that we need to figure out, but those are the batteries with the LCO that have a lot of the value in them. Ironically, the vehicle batteries have less cobalt, but we expect that more of these batteries will be coming back. So it's kind of a flip-flopped challenge. Little plug, we at Argonne have been working on a new recycling model. We're developing this model, and the hopes is that it will capture the entire battery life cycle picture. It disaggregates the various stages and processes that the battery goes through during its life cycle and evaluates the costs and the environmental impacts. The hope is that this will help accelerate the progress of the development of the battery recycling processes and infrastructure in general. We hope to make this available to everyone to use this summer, and hopefully it becomes a useful tool for everyone. A couple of quick slides. Electric vehicles have been around forever. Our work predominantly is with electric vehicles, so I have some electric vehicle slides. The vehicles started out as battery powered. There was no gasoline engines, and so in fact this is pretty impressive with a nickel iron alkaline battery, 144-mile range. That's at 12 miles an hour, which doesn't work today. In the 90s and early 2000s, the EV1 was brought out by GM, and that had an increased range. And as we move closer to today, we're getting into the 200-300 mile ranges. So quite impressive performance. And I do want to acknowledge help from Linda Gaines and Andy Jansen here at Argonne. Both contributed to this. And I'd like to thank Dave Howell and Sam Gillard, excuse me, from DOE's VTO office. And Access is where all of our energy storage is funneled through. So if you have any questions, feel free to contact us there. So that's all I have.
All right. Well, thank you, Jeff. That was great. That was a great overview of lithium batteries, some of the chemistry and what's going on, and why there are so many different things we're hearing about, but also their history and some perspective of where batteries have been and where they're going, and some of the challenges, particularly with the processing and making sure everything gets sorted correctly, to highlight. So thank you for that. We did have one question for you that came in. Is there a difference between lithium ion and just lithium batteries? This person has seen them labeled both ways.
Thank you. You know, I skimmed over that. That's a great question. There is a difference, and it's unfortunate. Lithium batteries technically refer to lithium metal. Lithium metal is actually a great anode for lithium ion batteries. However, there's cycling issues with lithium metal in those batteries. So when you talk about a lithium battery, it's usually a single use or primary battery that has lithium metal in it. A lithium ion does not have lithium metal in it. You have lithium ions that are going back and forth between the anode and the cathode, and they're intercalating with those materials in the anode and cathode.
Okay. One thing to clarify, in the video that you had, that was a mix, that was a lead battery processing facility, and a lithium battery was in that mix, in that box of lead acid batteries, which is what caused the explosion, right?
Correct. Thank you.
Okay. Great. And so one other question, and this is for some of our staff at EPA headquarters. We did have a question about the handling of swollen batteries. And let me find that here. So how should waste generators handle bulging batteries from a RCRA or a DOT perspective? In terms of handling or packaging, I think one of our speakers will be getting into a little bit of this as well, but I wanted to check in and see if anyone from EPA has some input to add on that.
Yeah, okay.
Hi, this is Dan Fagnant. I'm a chemical engineer in EPA Office of Resource Conservation and Recovery. So that's a great question. First off, we can try and handle the RCRA part of it, but DOT, you'd have to reach out to them for an answer on DOT's shipping and handling and packaging requirements for bulging batteries. Bulging batteries are a complicated issue. Sort of backing things up, before every battery bulges, it's going to be a lithium battery, ideally in a product, and these are going to come in a variety of designs, shape, sizes, different electrolytes, and these are evolving. Right now, it's pretty safe to say you're going to have some amount of electrical charge left over, you're going to have lithium ions, you're going to have flammable organic electrolytes. So determining whether or not this is a hazardous waste or it's a solid waste is a difficult process to go through. We have some concerns that when batteries are damaged, they may exhibit ignitable or reactivity hazardous waste characteristics. So what we would encourage is, if you're not sure whether or not you meet that characteristic, you should manage as universal waste. At the same time, most states are authorized to implement RCRA, so you could work with your state programs to solve these difficult hazardous waste identification issues. And while you're working with your state programs, I'd also like to point out that state programs can be more stringent than the federal program, so there may be additional requirements depending where you are in the country for your battery management. So if you have like a more specific issue with a specific type of battery or something, you could send us more questions either via the question or process on this webinar or through the feedback form at the end. So I think that's mostly what to say. I think it really depends on your specific batteries. So we can't really give a generic statement for all batteries.
Okay, great, thank you. We'll have a little bit more. Carl Smith is going to have some more information on the Call to Recycle battery shipping program. So Carl will discuss a little bit more from his program's perspective as well. So thank you for that input. We're going to move on to our second speaker, Michael Tempane. Michael is a Principal and Vice President of Process Optimization and Material Recovery at Resource Recycling Solutions. At RRS, he works with solid waste and recycling companies, materials recovery facilities such as MRFs, NGOs, major consumer product groups, international packaging companies, and the public sector. Today, Michael will be reviewing RRS's recent report that highlights the challenges that lithium batteries are having on the waste and recycling industry when improperly managed. So with that, thank you for being with us today, Michael. Go ahead, the stage is yours.
Thanks, Chris. I really appreciate it. So I'm going to narrow the focus and just talk about the solid waste industry and some recent new information. One thing for sure, the lithium battery phenomenon and its impact on solid waste systems hasn't been studied conclusively. And so we have to keep that in mind as I go through this. These are the first kinds of their studies, and hopefully they're useful and give you ideas for conducting your own studies in your own plants and developing KPIs and the like. First, Carl's going to cover a lot of this, so I'm just going to throw this up for a second. Since 2010, lithium batteries are more powerful, they're lighter, and they're way cheaper, and they're growing. Right now, there's 1.63 per person per year that are being consumed in the US of both lithium primary and lithium ion batteries. And there's no end in sight to their uses. They really make our life a whole lot better. And in the future, they have tremendous potential. One of them is solving the storage riddle for green energy. Wind, suns, and tides can't turn on or off at will. And excess energy going to storage is a good thing to have. This is something that in the future will allow full efficiency of those kinds of ephemeral power methods of feeding the grid. And it may reach household use within 10 years and augment what you have at your house. So this really isn't a technology issue and its benefits. It's the explosion of the use of lithium-ion batteries and the only really practical disposal system, which is the MSW solid waste system in the United States. But it is really, really a really good technology. It's the backbone of our mobile electronics revolution. And at the same time, the technology intrinsically is the fast movement of molecules. And if there's not protection within the system, it can cause thermal runaway, and we'll go in more and more of that later. And there's a ton of literature. I hope you go out and get your own opinions on this. But here's just some of the quotes. They have very high advantages in terms of how long they last, that's the discharge curve, and how much energy they hold. So they last longer and they do more things for and more powerful things. The problem comes in the solid waste system, and it's not limited to recycling, but the folks at SBWMA, Rethink Waste in California, South Bay Waste Management Authority, hired RRS to do a study and find out why there's a mismatch between the current public solid waste system and especially recycling and the way lithium batteries react in it, which is really lithium batteries needs to be managed quite different, because with power comes responsibility. And this picture of a battery shows what happens to all materials as it enters the solid waste system, as they are compacted and disposed either through recycling or through transfer stations and landfills. And things get crushed and punctured and ripped, as a matter of fact, and dropped. And the problem with lithium batteries, if a mechanical blow of any kind or a deformation causes a safety separator between the cathode and the anode to get damaged, there's a discharge, and that starts the thermal runaway process. And so much so that there are just tons and tons of manuals and information, including the International Air Transport Association, that show lithium batteries need special handling out of the norm. And certainly, they're pretty safe when they're used in everyday use in your households, as long as they're not dropped or mishandled, or you try and take batteries out of enclosed types of electronic equipment. But if you don't do that and you're just using it in the common collection and processing system, it's been known to cause fires. So these are some of the, more in general, first in the collection and the places where batteries could get damaged, and that is in dropping right at the curb into the truck, blade scraping in the well of the truck as into the compact area of a truck, the per square inch compression that these batteries receive. They can be next to metal, glass, and unloading and running over batteries with tires at transfer stations, and pushing materials with other container bodies, or putting pressure on them through a baler. and so forth. But there's a lot of places where a technology with this much power in it and batteries maintain some power even after they're discharged as a safety protection is a place where we can get a lot better at noting that they shouldn't be coming into these areas. The one thing that we found in the literature is that the cause and effect of batteries in the recycling system is getting more well documented as batteries get more powerful. And just recently, this is a December fire that happened at the Brown County Resource Recovery in the Midwest, and the battery industry has been on the road in the last year in public statements asking for trouble if you're throwing it away in the garbage system, the recycling system, and they really shouldn't go there. And Call to Recycle has made that plain, and Carl will get into that. There are other documented cases and building up that you can go on YouTube, but these are just a couple of them that I've been aware of personally, and more here. And then just March 17th, St. Patrick's Day in New York, there was a recycling fire that stopped the Long Island Railroad for a number of hours. So they are happening. They're happening with more frequency. We don't really know that frequency. There's a lot of study that still needs to be done. I did one anecdotal test. I was at a glass plant in Utah, and for 5 minutes, I just followed glass, and one of the last stages is to take out remaining metals, and they had a optical sorter to do that, and in that 5 minute period, and I would estimate 250 pounds of glass, we found 2 lithium-ion batteries that came out of the same location, LG, with different markings on them, and they should have been out of their casings to begin with. So as I said, Rethink Waste and South Bay Waste Management Authority commissioned us, and we set up a number of tests. One of them was to capture batteries at different places in the MRF, and the only reported batteries were those captured. The ones we couldn't see that were embedded in paper or in other places were not counted. What we found in this preliminary study, which is still going on, they're still doing the study after our engagement there, and Hillary Gans will be talking about that at Waste Expo. What we found is that in a given hour, if you're paying attention, you can get up to 5.48 batteries per hour. I will tell you that in the case of South Bay Waste Management Authority, they have a battery collection program where they put batteries on top of the recycling containers in plastic bags with their terminals taped. And there may be some confusion there causing this amount of batteries. But wherever I've been, there's widespread belief that batteries are coming into the plant, and that's the point of this. We talked a lot about this at South Bay, and we feel that everybody in the industry, it's an easy thing to just set up some KPIs and harden your plant. If you do your own counts for a week and you train on identification, you increase your fire watch, you make sure your suppression system hasn't been altered through retrofits, and you count your incipient fire causes. If you do those things, over time, it's going to give you a greater chance of surviving what could be a lithium battery fire in your facility. Anecdotal numbers aside, they seem to be happening in most parts of the country. We also did a study with the line managers in the industry. We had really good responses, and they reflected a large portion of the industry. And we want to gain insight into the issues and current preventive measures of lithium-ion batteries. Publicly and privately owned MRFs were talked to. We had telephone qualitative interviews with MRF operators where we asked 5 questions, and we created standard operating practices, including best practices and resource recommendations, some of which I just mentioned. And basically the survey did note, and I know this from my own history, I've been in this history almost 40 years, and I remember when in a whole fleet of 100 recycling plants, we might have 1 or 2 fires. And these days, you hear about 1 or 2 fires every 2 or 3 months in any plant you go to if you ask the question. So we do know fires are increasing. There are other reasons like propane tanks that come down to a personal size that you can use on small devices, but most of the managers out there are saying that lithium-ion batteries cause those fires, and we got a pretty good sample. We're pretty happy with it, and we're finding a great deal of batteries in the MRFs now, and that number is increasing. 38% are sure of it, but most say that they're coming in. Some other things that the MRF managers told us is that gratefully 81% don't accept batteries in their curbside collection. It should never go in the bin, and even outside the bin, consumers could get confused and probably shouldn't have it on the curb. They report that only 50% of the customer municipalities who advertise recycling programs talk about other places to recycle your batteries. This is an area where we can really improve, and something that maybe some of the listeners on the phone can think about linking their recycling system and their battery system. And 58% suggested education was needed to stop batteries from entering. And then on the right, we have the minimum reported fires at MRFs the last 2 years based on our sample sizes. And that number may be much higher because there's a lot of barriers for a MRF manager reporting a fire. First, he needs to know about it. Second, if they put it out right away with a fire extinguisher, there may not be regulations to report it to a fire department. Third, they may not know the cause, etc. So then we talked to the executives, and interesting enough, the executives didn't have the same urgency that the field managers did, and we thought that was an area for improvement. Some really did, like Rumkey and Casella and others, saying it was a really big problem, but most executives felt in the myriad of problems, and MRFs are facing a lot of problems these days, they knew it was happening, they had their eye on it, but it wasn't as big a problem as others felt. They also were remarkably uniform in that batteries weren't the only problem, propane tanks were, and hot loads were, which could be lithium batteries. But we don't know enough, and it's just the tip of the iceberg. One thing they did say, which I think too, is recycling symbols on batteries are very confusing, and that needs work. And here's the label on batteries, and the European symbol for don't put it in curbside may not work here if you include it with a recycling symbol. Unfortunately, a lot of different kinds of batteries have both these on the sides of their battery. And someone may feel, oh, don't put it in the garbage, but I'll put it in the recycling. This needs to be tested, and needs to be tested scientifically, but it's a worthy hypothesis. It's gotten to the point now where there is a group organized in Washington working on this. It's a working group between the different associations with Ann Germain's leadership at NWRA and George Kircher at PRBA. And it has everybody who is involved in the solid waste chain, supply chain involved. And they first thing that happened was we learned about the new Call to Recycling training, which Carl will be going through. And then we're gathering best practices and uniform information for a communications plan. And what you see here is just some of that information. It's not done. This is a draft. But for the different sectors, what's the issue and what's the remedy? and I know this slide's kind of hard to read, but for material recovery facilities, they know they got to educate their customers, they got to educate their own employees, and their corporate safety managers need to be involved. The sorters need to know how to identify batteries and so forth, and what to do to put out incipient fires when batteries get there. I kept this focus narrow because the problem really is one of the solid waste system not being prepared to handle the evolution of what we consume. And it's nobody's fault. This is a great technology which is going to lead us to our more and more mobility for longer periods of time. Unfortunately, the solid waste system is not hardened enough, in my view, to do this. And much more research, I think, will confirm it. And right now, this is the state of the research. So thank you very much, and I'm ready for some questions.
All right. Thank you, Michael. Thank you for sharing the results of your study and your experience as well. We're waiting for questions to come in, so people feel free to go ahead and use the question box to submit any questions, and we'll ask one or two of those. There are two quick questions that came in about some terms that you used. First off, what is a KPI?
It's a key performance indicator, and it refers to a metric that you can set up to measure incidences, like how many fires are you having in a year, and what kind of fires should be reported, and how many times did you have to use your fire extinguisher, and what did you use it for, or how did you put the fire out. It's measurement. So key performance indicators, and they can set up a number of ways. So that's.
Okay, thank you. Another question is, what is a hot load?
A hot load refers to a generic term where a truck emptying material onto a tip floor is smoldering. The material, the pile that is on the tip floor, once it's been ejected out of the well of the truck, is smoldering. And the first thing that happens is the loader operator tries to push the pile apart and identify the source of the heat. And then, depending upon what it is, if they're trained properly, they'll put, if it's a lithium ion battery or something like that, they'll put it in a bucket of water, or if it's some other cause of the fire, they'll use their fire extinguisher to put it out. So okay. It's a generic term. Propane tanks can cause these fires as well. And most people who don't empty out propane tanks have the same problems that lithium batteries do in terms of what the solid waste system will do to them.
Okay, thanks. There are quite a few questions coming in about battery handling. What do we do now that we have just heard about some of the challenges there from Michael? Those are going to be covered by Carl in a minute or two. And there are one or two other questions, which I'm scrolling through right now to call up. One moment. Okay, one moment. So what is, maybe this is a better question for Carl. How are these batteries being handled in other countries? In Europe, for example, are they having a similar problem in their MRFs?
The literature seems to, there's a famous study by fire marshals in England that was done about a year and a half ago. The literature seems to indicate that they are. And in fact, that study is more in depth than what we're able to accomplish at one facility, and I would refer you to that study. But I'll turn it over to Carl for that one.
Okay. Carl, do you have anything to add?
Well, as Michael has indicated, the evidence is still somewhat anecdotal, so I wouldn't say that you can draw direct parallels. But clearly the U.S. is not unique in its challenges as far as handling lithium-ion batteries. They tend to be more developed and sophisticated in how they handle their waste and recycling in Europe. So it's not as prominent, it is not as dispersed as we see it in the U.S., but they're still having significant issues too.
Okay, thanks, Carl. Michael, do you have any thoughts on clear messaging on batteries? You referred to some problem messaging that may be confusing to consumers in certain markets. Do you have any thoughts on clear messaging?
Well, I've learned through being in this battery working group that this is a difficult issue and worthy of maybe exploration at another date. But batteries come in, thousands and thousands of configurations. One article I read said 31,000 different configurations, and each one has only so much room for labeling. Each one comes from a different manufacturer or for a different use application, or it's just product turnover. And because of all those reasons, labeling isn't consistent. The battery industry has taken it on its own and does try and get everybody to put good labeling on batteries. So I think Carl's better to talk about that than me. But,
okay.
And
looking a step down for a different route for material from the MRF, has there been an impact on landfills from these batteries?
Yeah, there have been reported fires. There's been 3 or 4 that have been in the media, and fires at landfills can be difficult, especially after you put daily cover on. And lithium doesn't need oxygen to burn, so it can, if there's landfill gas involved, it can cause a fire in a landfill, similar to other things in a landfill like hot loads that cause fires. Yep.
Okay. Are there any resources or organizations out there you could refer people to or point people towards regarding managing a lithium battery fire?
Yes, Carl's going to talk about that with their new safety program, which I think is excellent. And in terms of messaging, I do think clear messaging that this group is trying to develop in Washington would be really worthwhile, so that we could get it to all the municipal sector and people who have residential recycling programs. It would help a lot.
Okay, so let me ask the question, phrase it a little differently. Were there any resources, if MRF were to have a fire with a lithium battery, are there any resources that you found that would help them identify methods to contain and put out the fire?
So 2 things. Answering directly, what we've been taught through this group and through the literature, and it's out there, is that handling it by putting it in water is the best way if you can do that safely. Making sure it's away from fuel sources is also important, separating it from fuel sources, and making sure your fire suppression system is set up right, and you haven't compromised it by retrofitting the plant, are all important things that you need to do, right? So, but Carl's program is pretty impressive, and it goes through some of that.
Okay. And then last question here. Your report, is that available?
The report is public information at the SBWMA website under one of their meeting minutes. So I would think that being public, yeah, you could go out and get it. Okay.
All right, great. Well, thank you. There may be a few other questions for a little later on. So thank you, Carl, and thank you, Michael. We're going to move on to Carl next, and thanks to everyone that's put in questions. So our third speaker, we've had a lot of people anticipating Carl with a lot of questions about battery handling and management, is Carl Smith, who is the CEO and president of Call to Recycle. He oversees the organization's strategy, its education efforts, and its stakeholder relationships. Today, Carl will be informing us about the Call to Recycle's work to build consumer awareness and a recycling collection infrastructure for lithium and other single-use batteries. This work helps to keep lithium batteries out of the curbside recycling and waste stream. And now on to Carl. Thank you, Carl. Go ahead. The stage is yours.
Thanks, Chris, and thanks everybody who's joining us on the webinar. I want to speak to you about one important strategy to mitigate battery safety incidents, and that's recycling. Not just recycling batteries, but obviously it could include the products with batteries, although I'm going to focus most of my remarks on the battery itself. First, let me just give you a quick overview of who Call to Recycle is. I'm not going to go into too much on this, but we operate through the U.S. and Canada. We've collected approximately 145 million pounds of consumer batteries since our inception. We're a not-for-profit that was set up by industry over 25 years ago to deal with this issue, and in the course of our history, we've handled probably close to 30 million pounds of lithium-ion batteries. So let's just say we've got the marks to show for it too. We're funded by the manufacturers who put products and batteries, products that have batteries in them and batteries into the marketplace. And our fees are essentially established based on their sales into the marketplace. And we manage collection sites throughout, again, the U.S. and Canada. For sites like municipal governments and major retailers that are open to the public, we're a free program. For others, we charge highly competitive fees in order to ensure that these batteries are collected safely and recycled. We don't handle any of this stuff ourselves. We basically manage a program. So we use the logistics of transporters and sorters and private recyclers to do all of the dirty work. We spend a lot of time on our education promotion. Michael talked about that, but I'll get to that near the end of my presentation. We also handle a lot of regulatory and reporting and certifications and downstream verification to ensure that these batteries are handled safely and appropriately. And in that course of that, we handle thousands of customer inquiries via all sorts of medium all the time to try to deal with some of that. Along the way, we've had to make sure that what we do is certified and approved by a variety of bodies, most particularly the U.S. DOT. We handle in the U.S. 2 special permits under the U.S. DOT. One is to allow us to manage small quantities of batteries in our patented box. The second is to handle something that's called a damaged, defective, or recalled battery, and I'll get into that in a few minutes. About those are those ones that are bulging or show signs of inappropriate or damaged use, and we obviously need to have special permitting to be able to ship those. And we maintain R2 amongst other certifications to show we're doing this appropriately. So that's just a little overview on us, but I want to get into the meat of this conversation. First of all, I want to make a clear separation between lithium primary batteries and lithium ion batteries. Lithium primary batteries are some called just lithium. Sometimes they're called lithium metal. Generally speaking, those are single-use batteries with some specific purposes, and I've put some of them down there. The lithium-ion battery are the rechargeable batteries. They're gaining most of the attention now, and certainly for very good reason, given their widespread use in electronics and also in other places like EV batteries. But I don't want to neglect that almost all of what we're talking about applies to both lithium types batteries, rechargeable and primary. And I also want to make sure you know that lithium-ion rechargeable batteries are not the only rechargeable batteries that require some special treatment when you're shipping them under US DOT regulations. But for the rest of this conversation, I'll refer to this as lithium-based batteries, if you will. Both lithium primary batteries and lithium-ion batteries, as you heard earlier on, have all sorts of sub-names and sub-chemistries. I won't focus a lot on those, but I will try to help you figure out what you've got, if you will. The chart's courtesy of The Economist really tells the story that you got to make sure you understand on all this. is that not only has the number of lithium-ion battery cells sold into the marketplace gone way up, but the energy density of each cell has also gone way up while the cost per watt hour or per power, if you will, has gone way down. And so we've referred to this as energy density. The same size battery that before you needed for your cell phone, now more than enough suffices with much more power for a laptop or even bigger device. So they're getting smaller, they're getting more embedded, and they're getting more ubiquitous at a lot less cost. So specifically, if you're in the business of handling the recycling of batteries, the world has changed too. For instance, the cobalt used has more than tripled in price over the past 3 years. But the nickel is also, the price is more stable. People are moving away from cobalt to more nickel. How do you know? You don't. Certain devices that require high performance, like an iPhone, will more likely have cobalt. Certain devices that need just more constant power, like a Segway, won't. It'll be a lithium iron phosphate battery. More and more, these batteries aren't getting recycled, particularly in consumer electronics, because as they'll get into, they retain a residual charge. They're often going for reconditioning or repurposing. But the big thing to talk about, we refer to it by the acronym DDR, is the whole concept of what is a DDR battery. A DDR battery is a battery that has somehow been damaged in its use, is defective in some way, or has been potentially recalled. But let me focus on the first one, the damaged. A damaged battery, we see a lot of damaged batteries, and they fall into a couple different categories. The first and probably the most prominent one is when someone has tried to take a battery that wasn't intended to be taken out of an electronics device like a cell phone or a laptop and tried to replace it. And invariably, because of how these are attached to those electronics devices, it's almost impossible to take them out without causing some damage to them. And as a consequence, they're bent or scraped or have other sides of damage to them. Those are often called lithium polymer batteries because they don't have a hard case. They have more of a film or on it that makes them much easier to bend and, quite frankly, much easier to damage. And that, when you have one of those batteries, you cannot put them in the normal waste stream. You can't put them in a normal collection bin. Under US DOT guidelines, they require special handling, and what we call DDR kits, which we make available for a fee, but they're not cheap. I will tell you that right now, because of how specially they need to be packed in order to be able to be shipped under the law, because those are the ones that are most likely to cause a potential incidents, are the ones that have clear and obvious damage to them. That makes them more susceptible to be rubbing up or somehow the electrolyte be more exposed to be essentially inflamed somehow along the way. So I want to make sure that I call those out specifically. So when we get those lithium-based batteries, they go to one of 4 different sorters where they're sorted out if they're mixed. If they are going to then recycling either directly or from the sorter, we currently have 6 potential destinations that we use across 3 continents. Some go to Korea, some go to Europe, but many of them are either treated in some way, handled in the US and Canada, and I've listed those destinations. You can go to our website, which is on this at calledrecycle.org, to see more specifically some of those destinations. So, how do you identify a lithium-based primary battery? It's called often lithium metal or lithium primary. They may come in all sorts of sizes. I've given you sizes down at the bottom. They may be marked lithium or a lithium cell, but they come in almost indistinguishably from similar types of alkaline batteries or 9 volts or AA's and AAA's. So they're hard to distinguish, and more, the alkaline companies are switching chemistry to lithium primary batteries, and you have to look very closely at what you think is your normal AAA battery to see whether it is in fact a lithium primary or an alkaline battery, and I've given you some. And they will also come in buttons, and they may be marked with the CR, the numbers that could be 121. It will have a number for those 3 hash marks there. Similarly, a rechargeable lithium-ion battery, it may be marked as rechargeable. It may have the battery chemistry on it and say lithium-ion, or it may have a number of other abbreviations that I've listed there. Again, if it's a button, it would say LIR and then a 4-digit number. It may have one of our battery seals on it, or the generic Chasing Arrows lithium-ion seal. Or, and this is very important, we do see batteries all the time that are simply not marked. Most of those are from foreign, lesser-known brands that get into the marketplace a lot of times embedded or part of products and not as freestanding batteries sold into the marketplace. And I just want to forewarn you, you're going to say, but it doesn't have it on it. You will see some that don't. The major brands, though, the names that you know, will always have some sort of marking to distinguish what they are and who's made them. So the 4 most important things, if you leave with any 4 things from my presentation on this, are these 4. A spent battery isn't, particularly a lithium-ion cell. They a lot of times will maintain 80+% of their original state of charge. So when you have them loose, when you think it no longer is powering a device, it still has power in it, just not sufficiently to power the device you're using it in. So when you have it and have it in your hands, that's when you have to treat it as though it's fully charged and can still do what it was intended to do. Second, and I say this all the time, that while it is frustrating that your device's life ends when the battery is no longer working well, I strongly would like to deter people from removing batteries that are not intended to be removed. And I say that not because I don't want to further the life of the device, but from a battery safety standpoint, those batteries that are removed that were simply not intended to be removed are much more susceptible to some battery safety incident that's going to cause the problem. The third, whenever you're moving a battery that's a lithium-ion or a lithium primary battery, you need either to tape the positive terminal, the end that's got the bump on it, or you need to put one separately into a clear sealable bag like the one in the picture. And the fourth thing is, I'm not going to be quite as strident as Mike quoted me earlier, but I'm going to still say it like this: curbside is seldom wise. There are some municipal governments, particularly along the West Coast, that have created vehicles by which, that through bags and having them kept on the side of a garbage truck that comes pick, or a recycling truck that picks it up, have found a way to pick up these batteries and segregate them from the regular bin at the side of the road. But generally speaking, I strongly discourage people from trying to collect batteries, particularly these types of batteries, at curbside. Some have done a fairly good job of it, and I want to applaud them to do it because they've placed a lot of attention to it. But I worry every time I see a curbside program, and I don't think I've made that a secret with the people with whom we've spoken. So about a year and a half ago, we started a safety program that we've called Charge Up Safety. Michael referred to it as others have. And we had 4 main objectives. We had to, but generally speaking, it was our objective to reduce the amount of safety incidents we've seen in the marketplace, because they were happening at too great of a frequency. And while we can't stop malfunctioning products like a hoverboard at the bottom of the screen, we can make sure that the end of life of these batteries, that they're being properly handled and managed and get to the proper place they need to go. So I'm going to go into some of the things that we're trying to do to give you a sense of how seriously we've had to take it, and hopefully you'll get some ideas on this too. But first, we made a number of operational changes. We, for instance, our typical box that's been around for a long time, we have now insert a liner into it that's flame retardant, and we've tested it to lots of batteries up to a very high temperature, and it contains that whatever flames happen inside that box. We also always accompany a box with bags that you can put and individually wrap those batteries into. We also now, we send out about a quarter of a million boxes per year. And each one that comes back, we have inspected, and we can tell why and where a box came back, that the terminals were not properly protected or there was any incident to it. And we make available on our website terminal protection guidelines, how under US DOT rules you need to protect the terminals to ensure that you don't have a problem during shipment of these batteries. That obviously is available to anyone. And it covers all battery types, not just lithium-ion batteries there. And what we tell people very frankly, although it's a pain in the neck, if you don't know what chemistry it is, tape it and bag it anyway, because chances are it's not a lithium-ion battery, but you don't want to risk that. You simply don't want to risk it. Second, we've done a lot of consumer education. Go to our safety portal. You can sign up for a free training, a little quiz at the end. It takes about 15 minutes to go through to understand exactly what you need to properly handle and ship used batteries. It has a video version of it, not just a slide version of it. You can take the training. We can send you the certificate. You've completed it. We also have done a number of safety elements to consumer outreach events to try to train the general public on how they need to handle and manage lithium-based batteries. And finally, we set about to require every one of our collection sites to successfully complete training in order to continue to participate in our program. And as at the end of last year, we're over 20,000 sites that have gone through this training to make sure that they know exactly what they need to do to properly handle and ship lithium-based batteries. And again, you can drop me a line or go to our website, and all of this is free to the public for you to take and to understand and to get trained on some of this stuff. So my contact information is there, and the web address is at the bottom left of the page. Go to the safety portal on tab, and you can get all of those materials there to better understand how to handle this. Chris, I turn it back to you.
All right. Thank you, Carl. That was great. A lot of good detailed information about how to manage these batteries. There have been quite a few questions coming in. We're not going to be able to get to all of them, but a few that came in earlier were, you covered lithium batteries, alkaline batteries, AA's, things like that. How should people dispose of those? Any insight into that?
If they are, in fact, for certain alkaline batteries, they don't need to be bagged or taped. There are people who can recycle them. Depending on where you live, they may or may not have to be recycled. California does not allow you to landfill them, does seek to have them recycled. We do some of that. We don't do it for free, but there are lots of other people that recycle alkaline batteries.
Okay, and I've had two questions come in about the geographic coverage of the program. One asking about Washington and another asking about Hawaii, and some people asking why the program wasn't available there.
Well, it is available in Washington, and in fact, we've spent a lot of time. We've had over the last 5 years several collection events in the state of Washington, so it is there. You may not know it's there because We don't brand it like that. So if you drop off a lithium-ion battery in a Home Depot or a Best Buy or a Lowe's or some of those locations in the state of Washington, they all end up with us. Hawaii is different. We've had a very, very limited presence in Hawaii because of the difficulty placing batteries like this and getting them to the mainland. And so we have historically tried to focus on one or two major retailers in Hawaii, although that presence has waned because of the difficulties of putting batteries on boats.
Okay. All right. There's another question about a deactivation button or a deactivation screw that someone was asking about that would totally discharge the battery. Is there something like that out there?
Well, there are devices that fully discharge a battery to make it benign, if you will. I'm not aware of consumer products that use a discharge screw like that. I suspect there undoubtedly are for more sophisticated industrial products, but those aren't ones that we generally deal with. So I'm not aware of a consumer product that has a deactivation screw, but that doesn't mean I know all products out there.
Okay. All right. Quite a few questions are coming in. I'm not sure that we're going to be able to get to all of these. Someone was asking about collection locations. Again, those would be available on your website.
Yep, there's a locator on our website. You put in your postal code or your zip code, and it gives you the closest sites near you.
Okay. All right. Well, great. Thank you, Carl. We may have a chance for questions again at the end, so if you will be available to answer those, that would be great. Thank you for all the good details, and also you've got a lot of good information on the website as well that people would be able to explore to find out more details about the programs as well, correct?
Correct, of course. Thanks.
All right, great. Thank you, Carl. We're going to have today's final speaker, who is Elizabeth Schussler of the Recycling Partnership. She focuses on program design, where she's busy trying to crack the code of efficient, effective, and replicable recycling communications. Elizabeth will present resources that the Recycling Partnership has developed to help address the challenge of educating residential recyclers of the need to keep lithium batteries out of their curbside recycling and waste streams. So with that, thank you for joining us today, Elizabeth, and go ahead, the stage is yours. Thank you.
Excellent, thank you. So the Recycling Partnership is a nonprofit. We're a national nonprofit. We're working to improve recycling across the country. We are able to do this work through the support of brands and organizations that want to see recycling improved for a variety of different reasons. And we are grateful to the EPA for having us join. They're a great partner as well. So we do this work in a number of different ways. We offer grants to communities. We offer them technical support and decision-making and communication tools. We have strategic partnerships. Throughout the industry, we know that the system as a whole has to be healthy. It can't just be one aspect of recycling be healthy, from all the way from the messaging, the collection, the municipalities, all the way through to the back into putting those materials to work in manufacturing. And then we're also working with standardization and data, because one of the things we know is that in order to improve, we all need to be speaking the same language and working from the same sort of concepts and playbooks. And historically, municipalities haven't always had the best data. And then as the industry grows and changes, it's important for us to continue to update those things. So all of that to be best practices where we can put those into strategies and actions and tools. So batteries is an interesting topic for us. We're dealing a lot with communicating to the residents of what to put in recycling. And we're seeing that communities across the country, probably throughout the world, are faced with contamination. Residents say in surveys that they want to recycle. They say they know what to recycle, but when their knowledge is tested, they don't actually, the responses aren't 100% confident or accurate. So with markets, the commodity markets being a little bit down currently, I'm sure anybody on the call who is following recycling or is part of it has been hearing about National Sword. We've had webinars and things about that, and we're constantly working on the front end to try and equip the communities to help the residents recycle right. And then, you know, most governments are on a particular budget or on a particular timeline where they can't quickly message for behavior change, and that the MRFs don't often have the access to the residents listening for them to be, you know, directly talking to the residents about don't put your batteries in here. So that's kind of where we come into the equation. So we know that through our toolkits and our messaging and our protocols, it's working. So this Atlanta Key Results is an example of a pilot we just ran in Atlanta. We also did pilots in Denver and Chicago as well this year, and we have, I think we're totally worked with about 600 communities across the US. But so in Atlanta, we message for reducing bagged recyclables, because bagged recyclables count as contamination. That was the #1 problem for contamination in Atlanta. We saw that our program worked to increase the capture of good recyclables in recycling, and have people not put them in their garbage, but to put them in recycling. Overall contamination went down 57%, and then for specifically that thing that we asked for, a decrease of 62%, which was exciting. These are the tools that we used in Atlanta. So this basic information card, this annual mailer of what to put in your recycling cart and what to leave out, and then keeping that message consistent through direct engagement. There's the OOPS tag or a cart tag. We tag the carts in Atlanta based on the behavior, so responsive feedback to what was happening at an individual household or an individual cart. And then this sort of general community messaging of don't put bagged recycle, you know, don't bag your recyclables and don't put plastic into your carts. I mean, I think the tricky thing is for from the resident point of view, I mean, the people on this call talk about recycling in a very, a much broader sense, but for the resident, when they think about recycling, they often think about their collection container, whether it's a bin or a roll cart. And so when we say the word recycle and we talk about how to recycle your batteries, that doesn't always make sense to the resident. That makes them think that they can put it in their cart. So in general, when we're working with communities, we want to encourage positive messaging to instill long-term behavior. And, you know, whether in education or sports training or marketing, you know, that encouraging people to participate in a good way is sort of a long-term strategy. But when it comes to a safety issue, like batteries or something that's going to get caught in the machinery in the process or is unsafe for the handlers, we're going to have to use a negative message to disrupt or halt that behavior. And too much of that negative message can be confusing. So all to say, you know, be strategic and selective and be very clear in how what you're asking residents to do. We want to incorporate all of the messages throughout all of the communications for the residents. It happens in a number of different places. And so when it comes to, like, specifically don't put lithium batteries in your recycling cart, we often see that those sort of special case messages don't always make it through all of the channels of communication. So we encourage communities to integrate their messaging and make sure they, you know, step back and take a look at what they're telling residents and where they're telling them, so that as customers have questions, they can quickly find those answers and reinforce their knowledge. We have a social media kit that has prepared posts that you can download, and I want to make sure I say that all of our materials are free. for communities, and even industry can use them. I know there are a number of different stakeholders on the call today. Please use these, take them and use them as your own. And we will be creating, based on survey results that you'll receive a link to a survey today, based on the results, we'll be creating some new messaging to help support this specific issue. And what we're going to be asking is, how are you talking to residents about this lithium-ion battery disposal, and what do you want them to do? So how are you reaching them, and what are you asking them to do? And so we'll create some messaging to support that based on those survey results. Again, I want to thank you guys for taking the time and listening. Please follow us on social media, Twitter, Facebook, and LinkedIn. And then also look for that survey, because we want to create tools that really work. We want to understand how we can best communicate to, at the best point of behavior change, because we do know that once the things get in the cart, they're hard to see. Once they get in the truck, they're pretty much impossible to see unless they're creating a fire. And once they're on the tip floor and headed up the lines through the material recovery facilities, they're going to get, if they haven't already been damaged, they're probably going to be damaged and damage the materials that they're mixed in with. So thanks so much, and look for that survey.
All right, thank you, Elizabeth. We have a few questions coming in, so people, please take a moment to put in any questions. And do keep an eye out for the survey. Again, that is a survey that the Recycling Partnership is doing and not EPA. So keep an eye out for that. We did have a question come in. Right now, we're waiting for some other questions to come in. Does the EPA publish handling rules for batteries by state if it is different from federal EPA rules? And we'll leave that to my colleagues in headquarters to answer. I think you guys should be able to get on the line for that.
Yeah, hi, this is Kathy Lett. I'm with EPA's Office of Resource Conservation and Recovery. The state regulations, most of the states are delegated to run their own hazardous waste programs. We don't publish on EPA's website the contents of each of those states' requirements because it would be constantly changing and a lot of information for us to try and keep track of. What we do have is a link to the different state programs on our website, and you can find that at epa.gov/HW generators. That's the hazardous waste generator website, and the link is in there. And if you can't find it, just search on your internet browser for state hazardous waste regulations EPA, and you will get to it pretty quickly. And there's a link to each of the state websites, and you can go through there to find out the individual requirements for each state, because some of them do match up with ours pretty closely, but some are significantly different.
Okay, thank you, Kathy. Question for Elizabeth. I'm paraphrasing the question here. Are there any battery producer members that you work with through the Recycling Partnership that are working on battery collection or recycling or awareness programs for batteries?
Not yet. We would love to have some battery representatives. We do have the Consumer Technology Association, which does represent a number of electronics manufacturers, brands, manufacturers there. But no, not directly the battery, but we would love to have, we would love to collaborate with and have some support from the battery people.
Okay. And Carl, your organization does have participation from the battery manufacturers, correct?
Yeah. Yes. Every major and most minor battery manufacturer participates in our program, as do most of the electronics companies too. As I mentioned on one of my slides, over 300 manufacturers participate.
Okay, thank you. And something else I want to mention, since Carl's on, is there were quite a few technical questions about battery management and some of the specifics about the call to recycle in their DDR box. So I think it'd probably just be best to handle those by people going to the website and then following up directly with call to recycle on any questions or more information they need.
I've already dealt with one by email that's come into me, but if you don't find it on the website, there are several buttons there that can lead you to those DDR kits. You know, drop me a line or, you know, ask for more information. We'll be glad to help you.
Okay. And again, for everyone, the presentations are in the handout section of the GoToWebinar doc, which should be on the right side of your screen. And then the presentations and the recording will also be posted within the next 2 weeks or so. George will have a little more information on that at the end. So you can find that information on EPA's website for those that were not able to attend, or if you'd like to review something. So with that, I want to thank, excuse me, want to thank everyone for joining. I want to thank our speakers for sharing their knowledge that they have and information about their programs. It's really enlightening and a lot of good information here. And I also want to thank all of you, all of our attendees, for joining this month's SMM Web Academy, and hope you continue to join us. If you have additional questions on lithium batteries, please contact Karen Pollard of EPA's Office of Resource Conservation and Recovery, or myself. Our information is posted on one of the next slides that will be posted on the screen. So this program is designed for people to attend that have interest in waste management. We want to make sure that you complete the evaluation and give us feedback on how we can meet your needs. We'll post the webinar audio in about 2 weeks and then the slides next week. Please join us for next month's webinar, where we will discuss concerns electronics recyclers are experiencing when they remove lithium-ion batteries from used electronics at their facilities. It will also cover best practices that reduce the negative impacts recyclers are experiencing, and there will also be a DOT speaker to address transportation questions. There were several DOT questions as well that we held off on, as there will be a speaker from DOT next month. So with that, we are at the end of our webinar. I'd like you to thank you all for joining us, and please register for next month's webinar to learn more about this issue and electronics recycling. So with that, thank you, and have a wonderful rest of your day.